In the first step, read data from files and match train values to train labels. When we loaded the dataset, we found some NA and NaN and empty value and question mark that are not acceptable data, so we decided to define them as missing values. After we recognize the missing value, we have to handle them and find a way to manage them. In the train data set, we had so many zero and irrelevant values that are not our intended data, so we replaced them with an A to be considered as missing data. Also, we have the same issue with the test data set, and we replaced the 0 with an A and considered them as missing values. Then we count the number of an A in each column. For handling missing values of the numerical features, we replace them with median in 4 levels. For example, here we group by our data by region and district code, then replace the missing values with median and so on. And for handling the missing values of non-numerical features, we replace them with the word others. We analyze the feature that seems to be redundant based on their values and similarity and remove them. For example, here the management and management group features are looks the same, and since the we have different values for management, I mean that we have more values for management, we keep the management and remove the management group. And then we analyzed the geological column diagram and find out the region is the best feature among them, so we keep the region and remove the rest of them. And at the end of the feature selection, we have 19 clean features. For handling the outliers, we define an interval and only accept the values that are between 5% and 95% of other data. And the values that are less than 5% are replaced with 5% interval, and the values that are more than 95% are replaced with 95%. Then we normalized our data set and subtract all the data from the beginning of the interval, so that our interval starts from 0 and then divide them to the range of the data. Then our data would be between 0 and 1. Since ML algorithms usually are not very compatible with categorical variables, we convert our categorical features such as public meeting and installer to one hot vector. And after we cleaned our data, we created 3 data sets: train one hot normal, train one hot, and train normal, to decide which of them works the best with our models.
Want to explain model selection procedure. As our problem is classification, we choose 4 different models, which I will explain. First, 3-1, which are decision tree, random forest, and neural network. For each model, I implement 4 steps to find the best accuracy in that model. The first step is selecting the best dataset that we had created in previous step, actually between these 4 datasets. And the next step is finding the best setting for the model to fit, and the third step is reviewing some worse features and evaluate the model again, and the last step is doing cross-validation with all of that settings and features and calculating the final accuracy. The first model is the decision tree, and at the first I try to find the best dataset to train, and after training we choose train original because it has best accuracy. And the next step, I try to find the best setting for decision tree model, and after finding the best setting I calculate accuracy after removing some features. And after removing these features, our accuracy got better, and so we did cross-validation with dropped features, and mean of accuracy was 77.85%. The second model is random forest, and at the first I try to find the best data set, and we choose train normal. Next step, we try to find best setting for random forest model. After finding the best setting, I calculate accuracy after removing some worse features, but after removing these features, our accuracy didn't improved. So we did cross-validation with all features, and mean of accuracy was 80.81%. So as random forest model had the best accuracy, we did prediction on the test set with this model, and we got actually 0.8128 classification rate. Third model is neural network, and at first we try to find the best data set, and we choose train normal. Next step, we try to find the best setting, and after finding best setting, because we know that one hot encoded data has better result, we try to do some feature selection and removing some extra feature in our one hot encoded data, but our accuracy not improved. So we did cross-validation with train normal, which is not one hot encoded, and mean of accuracy was 77.45.
In this step, we are building XGBoost model based on the data we obtain after preprocessing, and we try to improve the result of it by optimizing model parameters using cross-validation, and also the data preprocessing methods such as upsampling. The data used for training is normalized for scaling purposes, and it is also one-hot encoded. As the one-hot encoding method works better with XGBoost. I have used XGBoost package for the XGBoost model, and also Caret for upsampling. After loading the data, as you can see, the number of the second class is significantly lower than the other two classes. So here we have imbalanced data set. To fix that, I have used upsampling method on the train data after splitting the test and train data. After building the required data structures for the XGBoost model, we can use default or random parameters to train our first model. Here I have trained two models, one of them based on the upsampled data, so I can compare the results of the two models. After predicting the data labels, the class labels of the test data, we can compare the results by confusion matrix. As you can see, the first model using the original dataset has a higher overall accuracy, which is 80%. The second data does better in recognizing the second class label, but has overall lower accuracy. So we use the first model in the following steps. After the cross-validation, which has about the same accuracy as the model, I have used cross-validation for tuning the parameters to find the most optimal set of parameters. I have used this optimal set of parameters to train the XGBoost model based on the whole train set we had, and here is the model. I have used variable importance and applied it to the data set, but since it didn't improve the results, I haven't included I haven't included it in this report. Now, after loading the testset, we can apply the optimal model that we obtained to the testset to predict the class labels. And by using this model, we could obtain about 80% accuracy.